Okay, see Lindelof videos. How many times can two lines meet? So if you had just any random two lines and you tried to cross them as many times as you could, how many times can they cross at any given time? Right? How many times? It's a question about linear systems. And I think where we get to is this, and this is what we're going to try to get to today, to just explore this. Two lines can only meet either one time, right? Crossing like a T or a V or however you want to picture that, or zero times, parallel lines like train tracks running right next to each other, or they can meet an infinite number of times, like all the time. That's called coinciding lines. Coinciding lines are one line laid on top of the other line. It covers the other line all the time. So let's look at these three examples really quick, okay? So here's the first example. We get this equation. It says 4x minus 2y is equal to negative 12. And we graph it. And we're like, okay, this is what this looks like. There's just one line there. I see it. And then I'm going to graph another line next to it. See what happens. So here's the next line that we graph, and it's 4x. You see down here, 4x plus 8y is equal to negative 24. And then the next thing I'm going to do is graph them simultaneously. I'm going to graph them both at the same time and see what happens. And you can see they look like this. So I changed the color of the second line so you could tell it from the other one. But can you see that these two lines meet exactly one time? And they meet right. They meet right here, don't they? They meet perfectly right here. And we can prove this with this calculator. And go here to menu, and we can go to analyze graph and find the intersection, and then we can do this and move over here, and we can see that these two lines, the blue one and the red one, meet in this case at the point 6, negative 6, and it's the only place that they meet. So this is the last question. The last thing I want to talk about is, so we went over them never touching, like railroad tracks next to each other, right? Let's go on. Let's see what we get. So here's our railroad track example, right? We have the first equation that's 2x plus y is equal to 2. And then we have another one that looks pretty similar. It says 2x plus y is equal to negative 2. So everything is the same on this side of the equations, right? 2x plus y, 2x plus y. But on the right-hand side, they're different, aren't they? And you can see that these lines never meet. They're not getting any closer, are they? From here to here is not getting any closer. So those are parallel lines, right? So here we have these parallel lines. That's the second possibility. Here's the third possibility. I want to look at it with you. So let's check this out for just a second. I go here. I only put in one line so far, and it's that line right there. It's 2x plus 8y is equal to 6. So on the same graph, I'm going to try to put this other line and see what happens here. I honestly have no idea what's going to happen. So I'm going to menu. I'm going to go to graph edit. I'm going to put in my equation. It's a line. I'm going to go down to this, right? And I'm going to put this in, and it is negative 5x, so negative 5x, right? And then over here, I'm going to have negative 20, so I'm going to put in negative 20, and that's going to be equal to negative 15, negative 15. So we see the blue line, right? And I'm going to graph this on the same page and see what happens. Do you see what just happened? They're on top of one another. They're both there, but you can't see them. I wish you could see that underneath this red line, everywhere under that red line is that blue line. It's really hard to believe, but I promise you that that's true. So those are the three possibilities. So just going back to it. Possibilities. Lines can meet one time, right? They can cross one time at this thing called the point of intersection, otherwise known as the solution. Or they can never meet. They can be parallel, P-A-R-A-L-L-E-L, parallel. Or they could possibly be coinciding, that is, one existing right on top of the other one. So I hope this is really helpful. Let me know.